Okay, hi everyone. Welcome back. Uh, this afternoon we have Ejiro facilitating the lab on recommender systems. Ejiro is a technical writer, and some of you already know him because he gave the lab on web scraping a long time ago. So we're very, very grateful for his time for coming back to give another tutorial. And he's also a machine learning engineer. He has a degree in computer engineering from the University of Lagos. And he started his debut, according to him, in artificial intelligence with us at ASSS Lagos. So we always love the story. So this is an advertisement to our scholars in this ongoing cohort, if they want to come back to teach future scholars, would be nice. So Ejiro enjoys teaching, as you can already tell from him coming back to teach you. And he also loves anime, which is going to show us how much his love for anime is through his presentation, I think. Without further ado, Ejiro, the floor is yours and enjoy, everyone.
All right. All right. Hello, everybody. Can you hear me? Awesome. All right. So today we'll be taking recommender systems. I'm sure that during the morning class, Futse did like justice to that. I sort of peeped in and peeped out. I think I peeped in when she was talking about collaborative filtering, and from what I was hearing, it was like very, very awesome. So we'll just get right into it. But before we do, just to like more of reiterate some of the things she said and sort of like get intuition behind recommending and filtering and all of that. So I just prepared something. So we're going right into it now. Quickly, can you guys hear me again? Just so anything you can hear me, just like put this in the chats because I know my network is a bit tricky these days. All right, so a recommender system is a type of information filtering system. It suggests preference based on users' choices and their behavior, right? So we already understand that there are two types of recommender systems, or two paradigms to it, right? Oh no, three paradigms actually. So we have what we call the collaborative filtering, and it's divided into two main parts, right? We have the user-based, or what some people call user to user. So this one is finding similarity among users, right? So I don't know if anybody can like. So I have like this is just like an exercise. I'm not going to explain this. So from the class you guys had in the morning, um, can we figure out? So for this user to use, for this user one, user two, user three, we want to figure out for user three what his rating would be for this particular movie four, and what his or her rating would be for movie five. So anybody, what like just based on what you guys learned in the morning, what's your like lucky guess and all of that? Let me check the chat. I think folks already. Okay. Sarah said 5 and 3. All right. All right. 5 and 3. 5 and 3. Five. So everybody's saying 5 and 3. And why you guys say 5 and 3? Anybody? Why is it 5 and 3? Cost of user one. Similar interest with user one, exactly. So that's basically the answer. So it's 5 and 3, right? It has user three from the looks of it. Let's call user three Anna. Anna has like similar interest with user one, John or wherever. All right. So okay, same thing. Let's do that here. So item to item, right? It finds similar items based on the user's preference, right? And recommends that item to it. So all right, yeah, sure. Thank you, Damilola. So for this item to item, so we are basing it based on the movie right now. So based on the item, the focus is generally on the item, right? Items that are sort of like together. So quickly again, same thing we did for user to user, for the user based collaborative filtering. And can anybody just tell me what's movie 4 for user 3. What do you think he would rate? What do you think she would rate it? And movie 5? Anybody? All right. Just drop it in the chat. Okay, Sarah is saying 5. 5. So this 5 is it for movie 4 or for movie 5? So I'm saying 5 and 2 for movie 4. All right. So this is fairly simple, right? Yeah. So the lucky guess and the simpler guess will be like 5, right? Because from here we can see that when for movie 4, for movie 1, person chose 5. So you can see that each movie there are like similar interests between. There's this similar interest between these movies, right? So makes sense. And so just to note, what do you note? Something to note, right? When it comes to collaborative filtering, item to item is basically is the most used, because one thing is user behavior will generally change, right? People change, people grow, people evolve, people stop liking. Back in the day, um, I sort of used to like horror movies, but now I don't even want to see horror movies because I'm like, why am I making myself afraid for no good reason? Yeah, so people evolve, people change and all that. But generally, items do not change. And a horror movie last year is a horror movie this year. Right? Well, except you go to an apocalypse and the horror movie becomes child's play. You get? But in proper reality, it's still the same. Right. So and you guys talked about content-based filtering. So it recommends items similar to what users liked before, right? So if you've seen something before, sort of like just gives you it recommends that kind of something similar. All right. So I'm just rushing through this. I'm not going to we don't have to stay here. So another what's the word now? Another concept we have to understand as we go into recommendation systems is what we call similarity measures. Right. So usually, right, recommender systems, they sort of like, so for example, let me come here. So for movie 1, so this is very vague, right? So for movie 1 and movie 5, or movie 2. So movie 1 may be a horror movie, movie 2 may be a comedy, movie 3 may be horror and comedy, movie 4 may be a documentary, right? So what um these recommender systems do is that before they start recommending, they have to like create what we call embeddings. And long story short, we don't need to go too deep, but these embeddings are just categories. So you have horror movies, you have fictional movies, you have sci-fi, you have this, you have that, you have ones that are a mix of both of them. So if it's an item, for example, you have pastries, you have dairy products, you have furniture wares, you have men clothes, you have this, you have that, you have that. Do you understand? So just basically creating categories for like different parts. And so one thing we now want to, and for users to, based on their interests, so we sort of like group them into categories also. Then what we try to do is to find the similarity between each of them, right? So three prominent method we use, right? So these are like just simple methods, methods we use. So we have cosine similarity, which we'll see later in class. We have dot product. Dot product is always very, we use dot product when we are doing matrix factorization, which we'll also see, and Euclidean distance. Euclidean distance is generally, so you guys are already coding and you're already doing your mean square and all of that. So distance between loss and distance. So yeah. So because I'm not supposed to like talk and do all of that. That was done in the morning already. So let's get straight into it. All right. Um, so yeah, we'll be doing an anime data set. So as Tej mentioned, I still enjoy anime a lot, right? So yeah, so that's why I chose this particular data set, and we'll be playing around with it. So yeah, so to sort of like understand recommendation properly, you have to understand your data set properly, right? A quick overview is that this data set contains user preferences from data from over 70,000 users on 12,000K plus animes. So there are two data sets, right? Now, So what we want to do here right now is we have two data sets. One data set is the anime data set. It contains everything about the anime, right? The other data set is the user data set. And this user data set is based on the rating. So if you look here, you have the anime data set. The anime data set has a rating, right? The anime data set has a rating. Same thing with the rating data set, has a rating. So it's basically two different data sets, two the same data sets, but they have to separate them. So let's get straight into it. So normally you import your code. Okay. So yeah, hello, can you hear me, guys?
I can hear you.
All right, cool. Can hear me. I'll just put the chat beside me here. All right. So the first data set, so you import pandas and non-pan, every other thing, right? So we are reading. So I just saw that Teju messaged me about having this, you guys having this data set. I am going to drop the link to the drive. I think I shared the drive. Can you give us the notebook? Yeah, it was shared already. I think it was shared already. The link to the data set. Thank you so much. So, all right, cool. So this data set contains the anime ID. Let's quickly just go here. So the anime ID, so it's the unique identifier for the anime, the name of the anime, the full name, the genre, what is it action, is it whatever, right? So the type. So for animes, there are like different types. So there are animes that are just movies. There are animes that are TV. So TV is basically just series, and they're like over. Somebody raised his hand. Sure, shoot. Somebody raised. Yeah.
It's asking for access.
Sorry, I didn't get that.
That link is asking for access. The data sets link.
Okay. All right. Give me a minute. Just give me a brief minute. Okay. Teju saying updated. So I think it has been updated. Can you access it now?
Yes. Thank you.
All right. Good. Well done. All right. So I think I pretty much rushed explaining what the data sets are. So let me just go. Let me just sort of like go back on it again, so we kind of like have better understanding. All right. So the anime ID is the unique identifier for a particular anime, right? The name of the anime, the genre, right? The type, how many episodes are in the show, the average rating out of 10 for the anime, right? And members, number of community members that are in the anime's group. You get so every of these particular, give or take, they are roles, but they are features on their own self, right? So every of these features, they have like a significance when it comes to like rating, right? When it comes to like rating, when it comes to like recommending also. So we also have the ratings of this anime data set, right? So and now remember, it is users that would rate it. So we have like a user ID, so who rate the person that rated a particular anime. Then we have the anime ID, right? We have the anime ID here. We also have the anime ID here. So the name of the anime that the user has rated, right? Same as here, right? And we have the rating out of 10. This is and also when it's -1, to say that nobody rated it at the time. You get a particular user did not rate it. This particular user did not rate it. He watched it well. And generally, how many of you watch Netflix movies and sort of like it at the end of the day or rate it? So, but Netflix also uses rating and uses what you watched to recommend to you. Do you get? So yeah. So here we are importing pandas as PD. We're importing NumPy, SciPy. From sklearn, we're importing cosine similarity because here we'll be using cosine similarity. So if you remember back in the day, cosine similarity is basically taking finding the angles of the vector, and we are dividing the magnitude. So it's A plus, I think it's A dot B cos A over cos B. All right. So it's, I don't really get into like the formula of it, right? But that's basically what it is. So it's just finding the angle, taking the angle of two vectors and finding distance using that angle, right? Um, so so here we're importing it. So I have to like run all of these first because I know that I don't want anything to go wrong, right? So yeah, so this is the head, this is the first anime data set. So this is the ratings data set, right? Now, so generally before building any data set, before we start processing and using this particular data set, we want to drop missing values, we want to handle things properly, right? So here, if we so here we are just limiting data set. So it's, remember, it's about 73k users, right? So we're just limiting it to just 10k users for the sake of our compute system, right? Now my compute system basically. I'm using Colab, so let's just stick to, so at 73 it will be too high to take a longer to make it take at 73k to take a longer time, right? So that's the idea here, right? Um so here, what we're doing here is we're taking the rating, so we are replacing every minus one. So every place, so we're doing that for every minus one rating, it means the user did not rate it. So we are replacing it with a non-value, something that is not available. So that we can like compute properly, right? And also in the ratings, we are also dropping duplicates, right? We don't want so a user may rate an anime, he may not rate an anime. So or a user may rate like 3, 4, 5 animes, right? So we don't necessarily like want all of that right now. So we're still like removing that. Then we are creating, so also we are creating a user item interaction matrix. Now, um, quickly, anyone please, in the morning, I think that was when I joined in. Fusi was talking about a what do you call it now? She was talking about matrix factorization. She was talking about the weighted rate. I think what I joined was when she had the whole um weighted weighted value. So quickly, anybody, matrix factorization, what do you understand by it before we delve right into it? We're not going to like go deep into it, but what do you understand by it? Quickly, anybody? Hello? Hey guys, I'm waiting. Hello? Wait, quick one. Can you guys hear me? I hope I'm not out. Hello?
We can hear you, please. You can hear you very well.
Okay. So yeah, if you can hear me, I was asking a question. Who spoke now?
Elijah was on that. Actually, I came in to the lecture
Okay.
late, so I came in very late. So I mean, but I think
Okay,
I
you didn't get
saw
that
it.
part.
I came in very late.
Okay. That's all right. Who else came in quite early? And so Elijah, quick one. Since you came in late, so far, what I have been saying, do you get it?
Yes.
Awesome,
I'm
awesome,
okay.
awesome, awesome. So I'm waiting for any other person. Maybe just count to 5. If nobody would move on. All right. Let me do this. Sorry, who was that? Okay, Kosiso.
Yeah,
Yeah,
yeah.
I'm
I know
listening.
it was something. The I know it was something related to dot product of matrix. It's how to answer the question.
Okay, okay. I'm listening. Go ahead.
Yeah, I was saying that I know that what you're asking about, like the factorization stuff, right? This
Yeah.
getting like a dot product, like trying to get
The dot product. Yes, basically. So you are taking two. Yeah. Correct. Absolutely correct. So right, you are taking. So you saying dot product pretty means you sort of like have the intuition behind it already. All right. So it's taking like two different what's what now? Two different data sets and like finding a dot product between it and more or less like expanding it, right? So that's basically it. Once the moment you said dot product, I kind of figured you get the idea. So, but just for like every other person, right? So it's basically taking the user, the product, and the rating they give, right? And sort of like what's the word now? Multiplying both of them together. So let me give you an example. If you multiply 5 by 3, 5 times 3, you get 5, right? If you do it 2 by 2 matrix with a 3 by 2 matrix, usually you should get, I think, a 3 by 3 matrix, right? So more or less like something that just sums up the entire matrix. Right, so that's basically matrix factorization. So what we've done here, what we've done here is to say, so we are creating a pivot, right? So we are saying from the ratings, right? Ratings of pivots, right? We are saying take the index should be the user, the columns should be the the anime ID, then the value should be the ratings, right? From the looks of this, you can see that a lot of users just gave non-values. They did not rate at all. And for some users, this is none. So none here, the simple guess here is that none here is that they didn't even watch this particular user did not watch this particular anime. Right. So there's no rating for it for this particular user. Do you get? So it's not even -1 or 1 or any other value. Right. So let's just go straight into it. Enough talk. All right. So to implement the user-based collaborative field trade, we need to calculate the similarity between the users based on their ratings, right? So like what we did earlier on, we just took their rating and ratings just give us like the similar interest. If you rated it 5 and somebody rated it 4, it means both of you like it, both of you are somewhat the same, right? So we can use, so like I said earlier, they are sort of like they are different when it comes to recommender systems, they are like different there are different ways to measure. So you can use cosine similarity you can also use Pearson correlation. For people in like the whole stats and everything, you know what Pearson correlation is. Let's not go into that for now. So we want to say user similarity. Now, user similarity equals to cosine similarity, user item matrix. So that's this. Then fill any. So for every non-value, we are filling it with 0. All right. So it's basically if you did not rate it, we are just sort of like throwing it away. All right. So now I want to make recommendations. So this is I'm sure over the past 16 weeks, everybody has been learning like how to code in Python. So just follow me. I'm going to like explain each line of code as we move. So just sort of like follow me. All right. Hello. I just have to ask. So far, we're good, yeah? Hello?
yes,
All right, awesome. Awesome. All right. So, let me do this. Let me do this. so that we can see what it looks like. So to make recommendations for a particular user, right, we want to identify users with similar interests to this particular user. And so the similar interest is basically items they've rated positively, right? So if somebody rated, so also it could be items they've rated negatively too. So if somebody rated a movie 5 and somebody rated a movie 1, another person rated it 1, another movie rated it 1, the other person rated it 1, you can see that they're like similar interests. They did not enjoy that particular movie. Do you get? But in this case, we're just going with the more positive side, right? So we are creating a function based on user record. So it's taking in some values. It's taking in the user ID, right? It's taking in the user ID. It's taking in user matrix. So this that we created here, all right? Then the user similarity, the cosine similarity, right? And we are limiting n. N here is basically the amount of movies we want to like check how the amount of movies we want to use to the amount of movies, animes and ratings. Why am I saying movies? The amount of animes and ratings we want to use to compare both of them, right? So basically, so to get the similarity scores for the target user, so here we are saying user score equals to user similarity. Then we are saying user ID -1. So basically, we are taking minus the how do you explain this now? How do you explain this? Sorry, give me a minute, guys. All right, good. So user scores here is basically user similarity. The user similarity here, that's this -1. So for that particular user, right? So for similar users, we are taking any user with this particular user ID here, we're just taking them in, right? Then we are creating a list of the recommended animes. Then we are running through everybody based on user score. So we are writing a for loop, say for user score in similar users. One here is basically telling us we don't include the main user, right? So rated anime equals to user item matrix in the log of it, taking index -1, positive rated anime. This then we're taking in the index, right? So if you run this, it's supposed to give us lists. Oh, what am I typing? Oh, I just for a minute. Also, quick one. So far, what I explained here, do we get it? Hello? 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 Um, Okay. Okay, thank you. So just wait a while because so at 10K, see how long it's taking. So I just sorry guys, I just allow this to compute. So roughly takes like 3 to 4 minutes. All right, good.
I think we lost Ejiro to internet problems, sadly. You can use the time to uh, continue the tutorial on your own by reading through it and running the cells. Just trying to understand the tutorial that he has prepared for you while we wait for him to join, hopefully. By the way, the fifth assignment will be shared with you possibly today, which would be on my lab. If you can remember the content of the lab, that was week 11, nonlinear modeling. Be expecting it later today in your email. So far, do we all understand what Ejiro has explained up to when it is connected? Are you able to load the data and run the code?
I think it's the rating files still loading my end. It's large.
The rating is large. Oh,
Yeah, it's still loading.
okay. Yeah, because the size is up to, let me check again. What was the size again? You mentioned it in class just now. Like 73,000 by over 12,000. So this is a huge file. Okay. Are you using Colab? Yeah. Mount your drive on Colab. Lola, do you want to share your screen to show everyone how you did it? That made it work for you. If that's okay with you.
I'm using my phone for the Google Drive, I mean, for the Zoom meeting. So let me,
Okay.
um,
Okay.
don't know if you can see my screen.
I can see your screen. Or let me try to pin your video. Maybe everyone can see it now. Can you all see Damila's video?
So
Are you seeing it? Any people to confirm? I don't.
See.
You can see?
let it.
Yeah, it's
So I copied this to my drive, and from the drive, come
It's a
after
little bit blurry.
I
Oh,
mounted, is this
okay.
better?
So it's on your drive. So you have like the drive that
After
mount.
I copied it to the both of them to my um Google Drive. And after that, I mounted the
Okay.
drive on Kotlin using um this line of code. It's already in
Okay.
the So after that, I just went to the well, to
And
this
access it to it.
site, yeah, and then I drive, then I found a copy of anime CSV, a copy of written. So copied the parts and I pasted it here and here.
Okay. Thanks for the demo, Damilola. Um, is anyone else doing it like that? Is it helpful for you? I forgot who said that they're still trying to
yeah, I saw
load it.
that.
Was it yeah? Is it not working?
Yes. I put the file.
Okay, this is great hack. Thanks. Okay, so what else? I mean, I don't know if Ejiro will join. I'm sorry about that. Maybe I can just ask him to record the class afterwards if his time permits, but we can also use this period to maybe clarify any question you may have, and if I have answers, I will give. If not, we would ask everyone on the call and they can share. So now that you've all downloaded the notebook, did you run everything? Does it work? Are you getting any error? Are you understanding how to like train with that data and evaluate it. I think he did put some notes in his lab, which is very good. So you should be able to just read through and run the code. It's very well maybe that you will not understand some terminology there if you're not familiar, that's okay. Then you can ask that, what does, for example, if someone is not familiar with CFID vectorizer, which should not be the case because we talked about it in during the free text week. But it's also possible that maybe you forgot. So it's like, what does it do? This may be a question you want to investigate or any other thing. So do you have any questions so far, or you just take time? You just take the rest of the time to walk through the lab by yourself. Everyone is so quiet right now. Should I assume that you're all silently reading the notebook and trying things out?
Yeah, I'm actually going through it so I can
Okay, this
understand,
is good. All right.
so,
Okay, so let's just wait on the call for maybe another 10-15 minutes, if Ejiro is able to join. So I don't want you to waste this time, just read through it. And if he still doesn't join by then, I'd say we'll just have to reschedule, or maybe ask him to give the tutorial, make it recorded and available. Does that sound good to everyone?
yes, it's okay, man.
Oh,
Okay, I think
is
he's
he?
back.
Oh yeah, Ejiro,
Can you guys
I'm
hear me?
glad you're back. Yeah.
Um, how do I put this now? Well, sorry guys. For people that are Christians, this is why you should pray before you do anything because um, I don't know I don't even know what to say. I don't even know what was wrong. Well, now.
Yeah, glad you're back.
All right.
So so what happened was that um, someone could not load the data because it was very big, and someone else on it helped out, so which was quite nice, because they just talked about how they loaded it and they mounted their Google Drive
Now say it's Google
directly,
Drive.
so it made it faster to access the data. And so I just wanted to mention that.
Awesome. 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 Okay, I'm trying to share my screen. Um, sorry, Tej, you have to do the
Okay, just a moment. Mm, should be good now.
oh yes. All right. All right. Hello?
Yeah, you're audible.
All right. Thank you. Okay.
Oh no, we lost him again, it seems. All right, this is too much interruption. We'll just ask him to record the video, if he has the time, so that you can still have access to this. I think uh, that's the most reasonable thing to do right now. Okay, so let's wait again for a few more minutes, and if he's able to join, I can propose that to him. And sorry, I'd hope that there will be interaction, but maybe we just record the video. You can just make the video if he has time, and then we can go over it in our own time. How does that proposal sound to us? Hmm? Anyone? Counter argument or counter proposal? Is anyone still on the call listening in?
Well, I think what you said is fine.
Ah, awesome. Okay. Thanks for saying something. It's starting to feel like I'm not all alone here. So let's just wait for like 10 minutes. I'm really sorry about this. And yeah, it is what it is. You can use this period to continue like with your uh, exploration, just reading through the lab and trying to decode. So I can entertain you for the remaining 5 minutes, and then we'll call it a day. I was looking at the week 11 notebook again because, like I said, I will be sending the details about the assignment, and I wanted you to um, explore, continue exploring the data set, or do another task based on the data set. So one of the things that the assignment is asking of you is to think about how to use the existing features that you have to predict the popularity of a song based on the specified data sets that we were working with rather, the Nigerian specified song data set. And see if you can, what combination of features, if can improve your data, your prediction. And maybe you could even think of augmenting the feature with some external features. So one thing that I thought about, which I needed to use beautiful web scraping for, I talked about this earlier in the class, earlier this afternoon, was that I had this idea that maybe I could just you look at another website to that that rank the popularity of data sets, and so I scraped that website. Uh, I scraped it for the top 10 songs, and if that top 10 song is in the Spotify data set that I'm working with, I just have it as like it's popular, like it's one of the top 10. So this is one more feature. And so I included a feature and I retrained the model, and I saw that that actually reduced the error rate for that particular task. So I was like, oh, okay, but it's reduced this very slightly, like it's not a lot. I was like, could we like do better? I just wanted to give you like a good baseline to start with. Plus, I was also curious. We sort of started this task in the tutorial lab, but we had very poor error, but we never really went further because we were running out of time. So, so then I was like, okay, what if we kind of like leak our feature by binarizing it and including it as part of the, sorry, leak the label. The popularized label is a continuous feature. So I was like, okay, what if we just have a binary one to say that if you're greater than 20, it means you're popular. If you're not, you're not popular. So, and I included that as part of the feature and so on. So this is not. I mean, I don't. I think it's like you're leaking the answer by just binarizing it. In any case, by introducing that into the feature, set has a very like it has a very high chance of reducing the error, which means that that particular binarization is effective. But it also depends on the range that you choose. So, for example, if you say that if the popularity score is greater than 50, from my experiment so far, it does not improve drastically. But anyway, this is now your task now to see a combination of features or like tricks that you can use to continue to reduce this error. Is it possible to reduce it further, or this just this is just the best we can do? So that is the homework, and I will summarize this uh, in a nice email and send it to you, and we'll give like 2 weeks, so the deadline will be up a week to submit that. And yeah, how does that sound to you? It took a while. I was supposed to send it to you a bit earlier, but just had to take care of other things. But Did you all hear me or not? Challenging. Uh, no, I mean it's explore it don't overthink it. It's more like it's more exploratory. So it's so the task really is just to have a model that best predicts popularity. So how do you do it? You have this set of features. Do you constrain yourself to this feature? Do you try to be more a little bit creative in, augmenting with external features? What kind of external features work for you? Things like that. So this is just what I hope um to see in the response, like in the notebook that you share with me. Okay. All right, everyone. I'm really, really, really sorry that we could not do the lab as scheduled. So we'll get back to you as soon as I can get a hold of each year. So enjoy the rest of your afternoon. I hope you use it actually to continue studying. If you've already booked this time for it, it's just an opportunity. And bye.